Here we're looking at example 3 from our 2.77 notes. We're asked to find the tangent line implicitly for this particular function at this particular target point. Now again, using step 1, we're going to take the derivative with respect to x on both sides. So we're going to take the derivative with respect to x on both sides. So then we'd end up then with the derivative with respect to x of x squared y squared plus negative 2x is equal to the derivative with respect to x of 4 minus 4y. Now going ahead and distributing our derivative to each item, we end up with taking the derivative with respect to x of x squared y squared plus the derivative with respect to x of negative 2x is equal to the derivative with respect to x of 4 plus the derivative with respect to x of negative 4y. Now, when we're just looking at the derivative with respect to x of this x squared y squared, we actually notice that this is in fact a product rule happening. And as a result, we're going to let this first one be f and this second piece be g. So we'd end up then again with f is equal to x squared, g is equal to y squared. Taking the derivatives of each, we have f prime coming out to be 2x. Really, again, that's a chain rule. So you'd have 2x times now the derivative of that inside dx over dx. Taking the derivative of y squared, well, that is also a chain rule. So this squared term being your outside function would give you g prime is equal to 2y. And then taking the derivative of that inside, you'd end up then with dy over dx. So just simplifying these up a little bit, we end up then with f prime is equal to just 2x because dx divided by dx is just 1. So that doesn't really change anything. This guy's already simplified though. Now again, for the product rule, we have f prime g plus f g prime. So then just for this first derivative, it would come out to be 2x y squared plus x squared times 2y dy over dx. Now the derivative of negative 2x with respect to x, that would come out to just be negative 2. On the right side, we have the derivative of a constant, that's just 0. This negative 4, we're going to treat as a constant and bring him in front of our derivative. So then really we're just taking the derivative of y with respect to x. So we'd have minus 4 dy over dx. Now we're going to move on to step 2 and solve for our dy dx. Well, getting all of our dy dx's over to one side, let's maybe move this negative 4 dy dx over to the other side and move anything that was not a dy dx over to the other. So when we do that, we have x squared, and this 2 we can go ahead and throw in front as well, since multiplication is commutative. So we'd end up then with 2x squared y dy dx. Adding this 4 dy dx over to both sides, we'd end up then with positive 4 dy over dx is equal to subtracting this 2x y squared, since it doesn't have a dy dx, over to the other side, and then adding this 2 to both sides. So essentially in that step we got all the dy dx's on one side and all the other stuff that did not have a dy dx onto the other. Just like before with some of our previous examples, we notice that they both share a common dy dx, so we're going to factor him out of both terms. So then we end up with dy over dx times 2x squared y plus 4 is equal to negative 2xy squared plus 2. And then just lastly, dividing both sides by this 2x squared y plus 4. On the left side, they just cancel out, leaving you your dy dx is equal to, this could be simplified a little bit more, but for right now, it's okay to actually just leave it alone. Because again, really our goal here is just to find the equation of the tangent line. You could maybe factor out like a 2 and simplify it up a little bit, but again, that's really okay because our ultimate goal here is really just the tangent line itself, not the simplified tangent slopes. Now, again, we've completed step 2. We've solved for our dy dx. Now we're going to move on to step 3. And again, that was substitute in your x and y for your target point. So our target point from earlier was 2, negative 2. Then the tangent slope at 2, negative 2 comes out to be equal to negative 2 times 2 times negative 2 squared plus 2 all over 2 times 2 squared times negative 2 plus 4. Negative 2 squared is 4 times 2 is 8 times negative 2 gives us negative 16. So this entire first part would become negative 16 plus 2 all over. This would be 4 times 2, that's 8, times negative 2, that's negative 16 plus 4. And as a result, we would end up then with negative 14 on top over negative 12 on the bottom. And so then negative divided by negative is really a positive, and it looks like if you divide the top and bottom both by 2, you end up then with 7/6. So our tangent slope then is 7/6. Now going ahead and using point slope, y minus y1 is equal to m times x minus x1. And throwing in our items, we have y minus, our y1 was negative 2, is equal to our tangent slope, 7/6, times x minus, our target x value was 2. Really, because we're subtracting by a negative, we'd really be adding that, so we have y plus 2 is equal to 7/6 x minus 14 over 6. So then really that's y plus 2 is equal to 7/6x minus 7 over 3. Subtracting 2 from both sides, we would then end up with y is equal to 7 over 6x minus 7 over 3 minus, really 2 is the same thing as saying 6 over 3. And as a result, y then is equal to 7 over 6x. Combining these now, we'd end up then with minus 13 all over 3. So there again would be our tangent line specifically at this specific target point to negative 2. Again though, that is example 3 from our 2.7 set of notes.